We'll begin where I think we should always start, and that is by making a scatter plot, which is really useful even though it's just looking at the bivariate or pairwise comparison. In this case, we're going to be looking at the relationship again between grants and salary. And here we can see that there is an unusual data point in the top right. And when I say unusual, I'm using that with quotes and using it quite leniently because it's really in the eye of the beholder here to a certain extent when we're looking at it graphically. Now we can see that this is definitely an outlier with respect to the X distribution by miles, but not necessarily so with regard to the Y distribution, right? There's more extreme values, and though that's not necessarily the center of the distribution, it's not necessarily an outlier. So what's important to remember is that right now we are looking at an outlier for one of our covariates. In order for an outlier to be influential or have high leverage on our results, it's going to have to be a strong outlier between predictors. So if we think that an observation may have high leverage or be influential in the way that we construct our fitted or regression line, i.e. the estimated coefficients that we have for the estimated relationship of the true underlying relationship, then we can look at our example and just see, maybe a good starting point might be just to check how the fitted line changes based on whether or not we include that observation or not. And so we'll run our regression first and then get the fitted line for our regression, and then we'll run the regression without it and do the same exercise. So we can start here by just kind of plugging in the estimated coefficients here. And now we're going to subset our data and see how the estimated coefficients change. All we're going to do here is, again, remove that one observation. So we're grabbing or subsetting all observations underneath that value and then rerunning our regression. And so what we can see here is that some of the coefficients change slightly. In fact, a couple of them changed by thousands. And so what we are left with, right, is do we really know if this one point had a lot of influence on the fitted line? So even though the betas changed in the new model, it doesn't necessarily mean that we have a better fit or a better understanding of how to actually model the data, because our R² value, the amount that is explained by our model, the regression sum of squares over the total sum of squares, didn't increase. And so we have to be careful about removing outliers or any data really, and we have to try to think about in a more principled way how we can try to classify whether or not an observation is truly impactful on our estimated coefficients in our model. And that's because observations that have high leverage are not going to necessarily be influential per se. So by that, if something is quite an outlier, that doesn't necessarily mean that it's going to impact the predicted value. So let's go through an example where the fitted line with a full data set, including all of our quote outliers or high leverage points, would look something like this. Now, if we remove, let's say, the top right observation, let's see how the fitted line actually would adjust. Oh, and we can see that it basically didn't move at all, right? The regression line essentially has not shifted at all. And the point here is just because something is an outlier doesn't necessarily mean that it's going to impact our regression coefficients and thus our predicted values. So again, to stress, this point did not have a large influence on our actual fitted model, even though it was an outlier. And so a point or an observation that has high leverage only has the potential to greatly affect the fitted model. And so we're going to try to talk about how we can distinguish which observations are actually going to impact our estimates.